So let's have a look at how 1Integrate is used inside the government organisations that we work with. Now, for us, government is one of the three key verticals that we work with, and it's probably the vertical that we have worked the longest within and have the biggest breadth and range of customers utilising the technology. So I'm just going to give a couple of examples of how 1Integrate is used that probably typifies a large number of solutions that we implement. So I'm just going to take you through two customers. The first one that I'd like to have a look at is the Ordnance Survey. So we have worked with the Ordnance Survey for a number of years. It creates all the topographic maps and other data for the whole of the UK. It is an excellent organisation for us to have in the UK. And when we started working with them, there are a couple of areas that we were looking at. First of all, they moved from a tile-based system to one continuous map scene of the whole of the UK, and we helped them achieve that. But more recently, we worked with them in terms of creating what is known as a product-ready database. Now, previously, OS would go through revision cycles of their data, and it might be every 3 months that they would then be able to release new data to their customers. But we work with Ordnance Survey in terms of putting in a system that actually would enable them to have what we term as a product-ready database, and that means that any particular instance in time, data can be extracted from that database and sent to customers because they know it meets its quality checks and is absolutely up to date and current. So what that means is, in terms of putting a data management process in place and indeed technology, it needs to ensure that as soon as changes to the data are actually created, they're able to automatically find their way through to this product-ready database and therefore be ready to be submitted out to customers. And that involves quite a pretty complex data management process, whereby as soon as data is changed, it will run through a very rigorous data validation process. It will then actually go through a rigorous data integration process into that product-ready database before it can actually be published. Now, there's a lot of complexity involved in that, and I've made it sound incredibly simple, but and we can certainly furnish you with more information around that, but it gives you an idea in terms of how the technology can actually be utilized, and 1Integrate sits at the heart of that data management process as a whole. Really why I wanted to mention the whole Ordnance Survey scenario is really about the amount of change that is going on, and therefore really the scalability of 1Integrate. So if you look at some of the numbers there, there are about 650 users within inside both OS and indeed their external contractors who are making changes every day, and that relates to about 4,000 jobs happening every single day, which means there's about 36 million features a day in terms of moving in and out of the environment. And actually, if you look at the number of features that are actually being updated, it's just over 300,000, which is an incredible amount of rapid change that is going on. And as I say, overnight the processes are run, so those 300,000 changes are automatically going into that product-ready database. And of course, one of the stipulations for OS, because of the speed and volume of data they work at, that system needs to have a 99.9% availability. So it really is a very robust and incredibly complex data management environment that we've implemented with them. So that's one example in terms of that whole data management process. The other example that I'd like to talk through is just US Census. So I have mentioned them earlier when we're looking at Data Gateway, but I just want to expand on this a little bit. So US Census is responsible for all the demographic, economic and statistical information for the US, and it's really, really important because it actually supports a number of elements, including the distribution of congressional seats, decisions on community services, and actually the distribution of over $400 billion worth of federal funds every year. So it's incredibly important organisation that needs to ensure the data it's making its decisions on is accurate. They have obviously their mission and their goal, and as you can see there, a lot of it really is about quality and about timeliness of getting data into the right hands. So it's an incredibly impressive organisation. Its objectives, again, you can have a read through what those objectives are as an organisation, but what's important to me is the high quality level of information, its cost effectiveness as a business, and the accuracy of information. And you'll understand obviously why, as we've just talked through what the data US Census creates actually supports. Now, US Census is slightly different to any other census organization that I've really come across in the world, in the fact that it actually has its own separate geography division. So in the US, there isn't a national mapping agency, which, for example, like the Ordnance Survey we have in the UK. So actually, the US Census has its own geography division that creates and maintains that geographical information it needs to support its decision making. And if we look at the type of data that's actually created inside US Census, or what's managed inside US Census, they have linear features such as roads, and they have boundary features, such as districts. They have geographical areas, and they obviously have a lot of addressing information, which is absolutely critical if they're going to complete their censuses, which actually happen every 10 years. Now, all that information is stored and created in a single database of information known as MathTiger. And up to date, US Census utilized a combination of their own in-house development and some commercial software to update that MathTiger database as new data becomes available. And actually the organization is split into two. So there is an IT environment with developers that, as you can imagine, are managing the commercial software, building in-house sort of applications. And then there are subject matter experts who really understand their data and are able to define the requirements associated to that data. So there are two very separate and distinct elements when looking at actually updating the spatial or the MathTiger database. Now, when we started working with US Census, they had a conflation process, and it's not easy in terms of what US Census has to achieve. So in effect, they receive data from 3,002 or over 3,200 different sources, and they're effectively the counties that exist inside the US. So they receive that data, they go through an ETL process where they'll transform that data so it's in the format that they require. They'll go through some data quality assurance processes on that data that actually comes in. They'll then go through a matching process where they'll take the data that has been received and match it against the existing MathTiger database to see where any changes are. And those changes create proposals which ultimately then will update that MathTiger database, which sits in an Oracle environment. Now, it's a good conflation process as a whole, but the big problem is much of it is done manually or is done with in-house scripts, and that causes some difficulties for the geography division. So first of all, there's a bit of an inefficiency in terms of those systems and processes that ultimately means trying to get the 3,200 files through the process at any one time, or indeed within a year, is very, very difficult. And in fact, in all honesty, it just doesn't really happen. And as a result, that means that data was out of date, and therefore that data was inaccurate. And that causes some real problems for US Census to function as they need to. And the biggest one, and why we got involved, is if we look at what happened in the 2010 census. So because the conflation process was so manual and took a while to come through, and therefore that spatial data holding wasn't accurate, it meant when they actually looked at their data holdings to conduct the 2010 census, they didn't have the right level of accuracy or currency of the information. And the result of that is they had to actually employ 150,000 people to go out into the field for 18 months and survey every single walk, every single street inside the US and collect addressing information, something they called address canvassing. And as you can imagine, getting 150,000 people for 18 months is an extremely expensive process. And in fact, when you're employing that number of people over that short period of time, or 18 months is actually quite a long time when you're considering that employment level, it's very difficult to make sure that every single employee is very conscientious in what they're doing. So is every street actually being walked, and indeed is every address actually being created? So it's a really difficult scenario for US Census, and something they wanted to ensure didn't happen again in 2020. So the net result is that we started working with the US Census, and firstly we had a look at the conflation process and looked at defining maybe a slightly more enhanced conflation process as a whole. And then we looked at the technologies that could actually be implemented to automate a lot of this process. So what you see on screen is the new process, and let me just take you through that. So in the same way, there are still those high level of submissions coming in, but we put an initial data validation process in place to ensure that the data actually coming in met some initial standards that were required. Once that was done, there's a crosswalk process, and the crosswalk process is very much transforming the data to ensure it meets the schema that US Census actually required. We would then go through a scrubbing process. Now, scrubbing is actually removing certain data from the files that are actually submitted, because as you can imagine, US Census only needs a subset of the information that's actually being submitted into them. There's no legal obligation for any of the counties to actually submit the data to US Census, but through a moral obligation they do that. But it does mean that they will send the files as is through to US Census, as opposed to doing any processing at the county level, so it meets the actual data content that US Census requires. So they need to go through this scrubbing process so they can actually remove data that isn't relevant to them. They're just able to process the data that they need. And this process is called scrubbing, which always makes me smile, because obviously with it being a Tiger database, it's affectionately known as Tiger scrubbing, which always, I don't know, puts a smile on my face. So once they go through the scrubbing process, they will then look to go through that matching process. So again, as mentioned in their original process, they will take the data submissions, compare that against their core database, and just automatically extract the changes that have actually been identified, and they'll create change proposals. Now, to give you an example of that, on screen you can see what is existing US Census data of linear features inside the MathTiger database. That is an example of the data that might have been submitted through from one of the counties, and when you overlay the two together, you can start to see where some of the differences are. In this example, you can see a couple of reshapes. That means data that exists both in the submitted data and the MathTiger database, but are actually in a slightly different geographical location, and that might be that the county data has been since surveyed to a higher accuracy. And you can see things that have actually been added. So those new blue lines are new roads that have been created. There's also a third sort of change that we identify, which is things that have been deleted, i.e. roads in this instance that are no longer roads, and that land has been repurposed for some other use. Now, the important thing is, rather than having utilize the entire data set, is actually to bring out those particular changes. And on screen, it looks a little basic, but is actually the true data. And you can see we've just identified things that have been reshaped and indeed things that have been added. And it's just that data that we can then utilize in the conflation process. Now, US Census, when we started engaging with them, wanted to make sure they checked every single change prior to it being submitted into the MathTiger database, which I totally understand. This is really important core data for US Census. So they just wanted to ensure that every change that was going to be made, someone just had a quick look at and they could accept or reject. So they've got a really nice Esri-based interface where we will submit just that change data into, and then as you can see on screen, it's a very simple accept or reject sort of scenario. If the data is accepted, it goes straight into the conflation process and submitted through to the core MathTiger database. If it's rejected, it means someone needs to have a manual visualization just to check that what is going to be changed in MathTiger is exactly what's required. Now, as I say, that's a little bit of a manual process, but the nice thing is what US Census have been doing over time is when they see changes that are continually accepted, they can change the process such that those change proposals no longer need to go through for an interactive review. They can automatically be passed through and integrated straight into the MathTiger database. So while at outset it's quite a manual and visual process, what they're doing is more and more increasing the level of automation when they are confident that certain types of changes automatically should just go straight through and update the MathTiger database. And that's what happens in that final processing step. Now, in terms of the technology, you can see that 1Integrate now automates all those sort of lime green steps within the process. In fact, we do use FME when we go through the crosswalking, but all the other steps completed using 1Integrate. And indeed, we have automated all those processing steps. What's interesting is we're actually looking with US Census in terms of data gateway, whereby it can have a web-based interface for submission of data through to US Census. But the key point is we've managed to automate the vast majority of this conflation process. Now, what that means is that because we can automate the process, it means we can get a much larger number of files automatically conflated into the database, and that means that data is far more accurate and way more current than it ever was before. So if we look at the benefits to US Census, there are a number of benefits identified, but I'm just going to have a look at two of them. So firstly, because the quality of the information or accuracy of the data, and indeed the currency of the data, is much, much higher, it hugely reduces the number of staff that are required to do that address canvassing. And in fact, they could save over 105,000 additional staff over that 18-month period. Now, there will always be some address canvassing needed because there will always want to do some verification of the accuracy of the spatial information, and indeed, it's not possible to automate absolutely everything. So there are some streets in the US that still need to be address canvassed, but there's a huge reduction in personnel that are required. The second big element is the financial benefits, and actually by using the new conflation process and ensuring we have that data more accurate gives a huge cost saving to US Census as a whole. So we looked at the actual numbers, and it's about a $5 billion cost saving to run the 2020 census over the previous 2010 census. Now, I'd love to say that 1Integrate is the only contributing factor for it, but that's not the case. But it is a big contributing factor. So if you look at other things that US Census are doing, such as being able to do the census online, for example, that has a big influencing factor. But in reality, none of those other areas will be able to successfully take place unless that spatial data is as accurate and current as it can be. So whilst we don't contribute to the full $5 billion saving, we certainly contribute to a large amount of it.